To find the area between the curves of 5x minus x squared and y equals x. To find area under the curve, what do? Integrate. Cool, that's what we're going to do. We want to find the yellow area up here. Where do you think I'm going to start to integrate this thing? 0. I'm going to start integrating at 0, and I'm going to continue integrating until 4. Why until 4? That's where it intersects. How do you know that that's where it intersects? Because it looks like that, right? It looks like that. It's not a great calculus answer. We can assume and hope we are correct. There is a mathematical way to find that, and let's look into that real quick. You could probably trust your eyes here and say that, yeah, right there it's intersecting at 4, but let's say we weren't that good at that, and I wanted to actually know where they intersect. What could I do mathematically to figure out where those two lines intersect? So I'm going to set 5x minus x squared equal to x. I know the answer to this question. The answer to this question is 0 and 4. We just found them by looking at the picture. But if I didn't know that, I could solve it. So this is a quadratic, so I'm going to subtract x from both sides to make this thing equal to 0. Hey, both of those things have an x, so I'm going to factor an x out. When is that thing going to be equal to 0? Well, when that guy is 0. And when that guy is 0, what's going to make that 0? 4. Hey, look, our two answers that we thought we already had, they're already there. Okay, we could see the picture, but if we didn't know, that is how we would find the intersection point. Everybody good at that point? Once we've established that, we are going to find the area between the two curves. To do that, we are going to find the area of the top curve minus the bottom curve. And so the key to this is making sure that the same curve is on top and bottom each time. So as I start here on the right, I want this area from the top curve to the bottom curve, top curve to the bottom curve, top to bottom, top to bottom, top to bottom, top to... Is the same curve on top the whole time and the same curve on bottom the whole time?
Yes.
Yeah, all of those lines connected pink to purple. We're good. Everybody understand that concept? The top line is 5x minus x squared. The bottom line is x. What do you think I need to do with those two curves? Subtract. Top curve minus bottom curve, dx. So I'm integrating from 0 to 4. 5x minus x, oh, that's 4x. Minus x squared dx. You can do that in your calculator, but I don't want you to do it in your calculator. Do that by hand real quick. It shouldn't take you forever. You get some kind of ugly numbers, but integrate. Go. What is the antiderivative of 4x going to get us? 2x squared. He increased his exponent divided by his new exponent, and the antiderivative of x squared? 1/3 x to the third. Increase his exponent to get him 3, divide by his new exponent. This is an antiderivative, so normally when we have antiderivatives, it's plus c. I don't need a plus c. Why not? It's got bounds, so I'm just going to evaluate this thing starting at 0 and going to 4. And so all I need to do then is plug in 4. 2 times 4 squared minus 1/3 times 4 cubed minus lower bounds. Guess what happens when you plug in 0? You get 0. So all of that goes away. That is my answer. This is a free response question, and so you could just be done and say, ta-da. All right, we could do that math here. If it were a multiple choice, your answer is going to be 1632 minus 64 over 3. If you type that into your calculator, you should get 10.667. Questions on how we did that problem? Found the area between the two curves. It's not anything that different than what we've been doing. Flip it over. It's really easy when they give you a picture and they make it nice and easy to look at. They're not always going to be that nice. On the back side there, we are finding the area between the two curves. 2 minus x squared and y equals negative x, and this is a non-calculator question. So you need to have a picture here. If you don't have a picture, then you don't know which curve is on top and which one's on bottom. So the first thing we're going to do is sketch this thing. Show me with your arms, what does y equals 2 minus x squared look like? That's a parabola, and it's a negative parabola, so it's going down. What's that 2 going to do to your equation? It's up 2, because think about it like this. That's the same equation. The plus 2 takes me up 2. It's a negative parabola, so I'm going to start right there, and then I'm going to graph. I'm going to try to space this out so it's not the worst picture I've ever drawn. Down 1, right 1, down 1, left 1, and then down 3, 1, 2, 3, right 1, down 3, left 1, right there. Oh, that was the worst picture ever. I was hoping not to. There we go. All right, there's my parabola. Then I've also got the line y equals negative x. Show me with your arm, what does y equals negative x look like? What's the y-intercept going to be? 0. It is a line that has a y-intercept at 0 and a slope of negative 1. So down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1. Whee. There is my graph. We are trying to find the area of the enclosed region. Find the area between the two curves. So shade in the area between the two curves. The area between the two curves should be this guy. Right there. Questions to that point? To find the area, we're integrating. From when to when are we going to integrate with this thing? Negative 1 to 2. Kyle, how do you know it's negative 1 to 2? That's where they intersect. He's looking at that and hoping that he's correct, but we graphed it by hand, so we knew it for sure. If we weren't sure, again, we could take both lines and set them equal to each other. Let's move everything over, so it's going to be 0 equals x squared minus x minus 2. Factor. Hey, guess what? I got x is equal to 2 and negative 1. We knew that, but we could solve it anyways. Okay, in order to find the intersection point, we could set them equal to each other and solve. But we could look at our picture because we drew a nice picture. In order to find the area between the curves, again, we want the top line to be on top the whole time and the bottom line to be on bottom the whole time. So as I do this, as I were to connect, starting at negative 1, I'm going top to bottom, top to bottom, top to bottom, top to bottom, all the way down. Is it the same line on top and bottom each time? Yeah. The top line was which one? The parabola or the line? The parabola. So it is 2 minus x squared minus the bottom line. It's minus negative x. So if it's minus negative x, it's really plus x dx. Solve that problem. Daniel, what's the antiderivative of 2 going to get you? 2x and negative x squared. Increased his exponent divided by his new exponent, and x is going to get you 1/2 x squared. That's his antiderivative. If it didn't have bounds, he would have plus c, but it has bounds, so he's evaluating this thing from negative 1 to 2. To evaluate that, he's plugging in the upper bound minus the lower bound. And so he's going to evaluate that thing by plugging in 2, so he's going to get, I'm just going to do the math. 2 times 2 is 4, minus 1/3. 2 cubed is 8. So this is 8/3. 2 plugging in for x, that's 1/2 of 4. That would be 2. That is what you get when you plug in 2 into the upper bound. That's plus 2, sorry. I had to cut it in half. Plus 2 minus the other guy. So I got to plug negative 1 into the other part. 2 times negative 1 is negative 2. Negative 1 cubed is negative 1. Plus the, times the 1/3 would be a positive 1/3. And this is going to be plus 1/2. Plus 1/2. If this were free response, that is my answer. I'm done. Let's say it was multiple choice. And we'd have to simplify it. Let's just do it once because we know how to not simplify. Let's simplify one time. So it's 4 minus 8/3 plus 2 minus 1/3 minus 1/2. To do this, the easiest way to do it is to combine all the numbers first. So 4, 2, and 2. What's that get me? 8. Then I'm going to combine all the things with thirds in them. Minus 8 thirds minus another third. That gets you minus 9 thirds, or in other words, it's minus what? 3, and then minus a half. 8 minus 3 is 5, minus another half is 4.5. There's my answer. Nothing is really tough. Nothing is new from what we've added. The only thing we added was, okay, cool, the intersection points and top minus bottom. Everybody good to that point? The majority of the time when we do these, you need to know how to do them by hand, but the majority of the time we're going to use our calculator to do them. And so there's a lot of calculator tricks. The rest of this chapter is all about understanding how to use your calculator and do it well. So make sure you can do that. So break out your calculator. They didn't give us a picture, so the first thing I want to do is figure out what my picture is. So you're typing in 2 cosine x and x squared minus 1 and looking at that picture. Do that for a second. I was working with a student earlier, and she had a picture, and her graph was super zoomed out. You don't want to be zoomed out. You want to change your window to kind of zoom in to what you want. Which of this part of the graph do I want if I want to find the area enclosed by both lines? That middle part, right? That guy right there. That's what I want, right there in the middle. And so I'm going to go zoom, and I'm just going to cheat and go zoom in. And just zoom in right to the center there. Oh, yeah. That's about perfect. That's exactly what I want to look at. Even though it's on my calculator, I'm going to write this on my paper just so I have a better idea. I would always suggest doing that, sketching this guy out. So here's what my graph looked like. I had this line here, and I'm going to even color code it. This is my blue line. And this was my red line. Which one of those two lines do you think was my cosine curve? The blue one or the red one? It's the blue one. If you don't know, then you should be able to plug in a point. Like if I plugged in 0, what is 2 times cosine of 0? Oh, that would be 2. And so the blue line is the 2 cosine x line. That means the red line is the x squared minus 1 line. You need to know that. If you don't know which line's on top and bottom, you're going to be in trouble. Cool. We're finding the area between the two curves. I want to know this thing. So if I want to know that part right there, I need to integrate. That's how I find the area between the curves. From when to when do I want to integrate? What do I need to know in order to integrate? Where they intersect. I need to know this guy right here. Unlike the other ones that were nice, easy numbers, that is not true here. I need to figure it out. So I'm going to go second, calculate. What do I want to calculate here? The intersect, number 5. So second, calculate number 5. I'm going to move my cursor over here to the red and blue line to right about where they intersect. I'm going to hit enter. Second curve, I'm going to hit enter. Guess I'm going to hit enter. Everybody make eye contact with me. You cannot round that number. If you round that number, it is going to be all wrong. Do not do that. You need to use that whole answer. And so you have one of two choices here. You can either write down that whole decimal on your paper, and then when you need it later, write it all in again. That works. Okay? Or instead, we're going to save that number. And we've done this before, but let me remind you of that. So once I've found that intersection place, I'm going to go second, quit, and go back to my main screen. Now from this main screen, the next thing I'm going to do is I'm going to hit the store button. Okay, that's this button right here. And it says answer, because it's giving me that last answer, that negative 1.2 number that I just had. It's answer, and it has an arrow. I want to save that answer, and you can save it as whatever you want. I'm going to save it as alpha A. I'm going to save it as the letter A. So I hit the green button and then the letter A. Now, anytime I type the letter A in, it's going to get me that negative 1.265 number. So let's put that on our paper. This was A. I would want to make sure that I labeled it. I would also on my paper write down A equals negative 1.2 6, 5, but I don't want to write down the whole thing. I'm just going to show some dots and say, hey, that's what A was. A was this point that they intersected. That is where I'm going to start my integration. I'm going to start at A. And I'm going to integrate from A until when? The other intersection point. What do we want to call that intersection point over there? B. So we need to find out what B is, because that's when we want to integrate till. And so I'm going to look at my calculator, and I'm going to go second calculate the intersection. I'm going to move this cursor all the way over. This is going to be a lot of fun. Oh my gosh, go. Yay. Move it over, hit enter. Guess, second curve, hit enter, curve, hit enter. It's the same number, it's just the positive version. It's not always going to be that. In fact, it rarely is that, but here it is. 1.265. I don't want to round it, so I want to save that whole decimal. Either that or I'm going to have to type it all in. So I'm going to go second quit, and I'm going to hit store. I'm going to save that answer as letter B. And so now anytime I hit the letter B, it's going to get me that 1.265 number. B is 1.265. I have to write it out. If you don't say what A and B are, you're not getting credit for that point. That's an easy point on free response. Don't waste it. What are your bounds? I know what they are. You don't have to get fancy. If I labeled it on my graph what A and B were, I write one A and B and I give me a little bit of a decimal, we're good. Now what we want to do is we want to integrate top line minus bottom line. During that time interval, which line is always on top? 2 cosine x is always on top. What's always on bottom? X squared minus 1. And so I'm going to do 2 cosine x minus x squared minus 1 dx. But if you wrote that on your paper, it would be all wrong. Why is that all wrong? It needs to be in parentheses. I'm subtracting all of that second line, so I have to put it in parentheses. X squared minus 1. Everybody good to that point? This problem is way more about setup than anything else. This is a calculator question. So as soon as I've gotten to this point, it's easy. I'm hitting math 9. I'm integrating from A to B, so I'm going to go alpha A. I didn't have to type in any numbers. Alpha B. Didn't have to type in any numbers. I'm doing the 2 cosine x equation minus the other one. I hate doing parentheses. I don't want to if I can avoid it. And so I already typed those equations in. So all I'm going to do is I'm going to hit alpha F4 y1, because I know that I typed in that cosine equation as y1 minus alpha F4. And I'm going to go down to y2 because I know I typed in the other equation as y2 dx. Hit enter. My answer is 4.995. That problem was all about setup. Once you found your A and your B, it was a lot easier. And you could do that problem in about a third of the time. It just took me to talk through it once you know it. But hopefully that makes sense as to what we did. Top line minus bottom line. All we had to know were intersection points. Questions are there?
So when we're doing the area, do we have to put any units or just?
Well, no, these are not units questions. It is just straight bald answers without a units. Questions on 3? Let's flip it over. Let's go to 4. On number 4, it says find the area in the first quadrant that is bounded above by y equals square root of x and below by the x-axis and the line y equals x minus 2. So let's draw a picture. You can use your calculator, but let's draw a picture. I think it's important that you understand what this looks like. It's bounded above by y equals square root of x. Show me with your arms. What does square root of x look like? Square root of x is that teapot graph. So we are starting at 0, 0. We're going up 1 over 1, up 1 over 3. There's my graph. It is bounded below, and this is why this problem is different, by 2 separate things. It is bounded by the x-axis, and so it is bounded by this line right here And it is also bounded by the line y equals x minus 2. So that means I'm going to start down here at negative 2. Slope of 1, up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1. It's also bounded by that line right there. I'm trying to find the area enclosed by all three lines. Do you see the shape that's enclosed by all three lines? It is this shape right here. This is what I'm trying to find the area of on this question. Everybody good to that point? Let's do it. We're going to integrate from when to when, starting at 0 and going until, no. We are going until 2. From 0 to 2. Emma, why do you think it's from 0 to 2? Oh, okay. That's one way we could do it. So she said she could find the area underneath here and subtract. That's going to be in part example. The next example is what that would be done in. But you're not wrong. That is the right spot. That's not a bad idea.
So you have to use 2 different functions?
Why do we need to use 2 different integrals here?
Because we're using 2 different functions.
Yeah. Say again. 2 different lower lines. The lower line is different. And so think about how I've said we're drawing the area from top to bottom. And so if I started off here, red to blue, 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 is it still top to bottom, red to blue? No. At that point it changed. And so we are finding the area under the curve from red to blue from 0 until what Emma said was 2. From 0 to 2, we are doing upper line, the square root of x, minus the lower line. What's the lower line going to be? 0. So you can write 0. I'm not even going to write anything. You can put 0. It's fine. Evan? Yeah. That's the first shape. That's this one. That's 1. That's the first area.